Hello and welcome to today's lesson where we're going to look at wave speed in a solid, which is part of the waves topic in GCSE Combined Science Physics. So in today's lesson, if we are successful and we learn, we should be able to determine the wave speed of a wave in a solid, which it forms part of the required practical you need to know for GCSE AQA Combined Science. So hopefully if we're successful and we learn in today's lesson, we should be able to understand how to calculate wave speed of a wave in a solid, calculate wave speed from experimental values, and explain why different measurements are taken and how this takes place in an investigation. So this forms the following part of the GCSE Combined Science specification 4.6.1.2 properties of waves, and in particular how to make observations to identify the suitability of apparatus to measure the frequency, wavelength and speed of waves in a ripple tank and waves in a solid and take appropriate measurements. So in previous lessons we've looked at the idea of wave speed. Wave speed is the speed at which the energy is transferred through the medium. It is the distance a wave covers in 1 second. Now, all waves have a wave speed. Now, the wave speed for all electromagnetic waves is the same. It is constant. It's 3 times 10 to the 8 meters per second in a vacuum, whilst an electromagnetic wave is a vibration in the electrical and magnetic fields. But the wave speed for a mechanical wave depends on the medium it is in, solid, liquid or gas. So a mechanical wave is not a vibration of the electromagnetic field, rather it's a vibration of the particles in a material. Now, mechanical waves tend to travel the fastest in solids and the slowest in gases, as it's easier for the vibrations to be passed on in solids as compared to gases. Now, in the most common example of a wave in a solid material in the real world is a seismic wave traveling through the Earth, which is a wave produced after an earthquake has occurred on Earth. Now, the wave speed can be calculated for any wave with the equation wave speed in meters per second is equal to frequency in hertz times by wavelength in meters. So in today's required practical, we're going to measure the wave speed for a wave in a solid material by measuring the frequency and by measuring the wavelength of these particular values and then multiplying the two values against each other. So our aim as an investigator is to calculate the wave speed of a wave in a solid from measurements of wavelength and frequency. So we would need a vibration generator, a signal generator, a string or a piece of elasticated cord, a set of masses, a wooden bridge and a pulley on a clamp, and we'd set up the apparatus as shown on the particular diagram. Now we would then switch on the vibration generator so the string or elasticated cord will begin to vibrate. We'd then see a clear wave pattern and then adjust the tension in the string or move the wooden bridge to adjust the length of the string so it would look like the wave is not moving. We then use a meter ruler to measure across as many half wavelengths as possible, as a half wavelength is one loop. You then divide the total length by the number of half waves, then multiply this number by 2 to give the wavelength. The frequency of the wave is the frequency of the signal generator, the power supply. We can then calculate the speed of waves using the equation wave speed is equal to frequency times by wavelength, and we can repeat the steps for different frequencies which achieve different numbers of complete waves on the string. So to set up this investigation, a pulley is secured on the end of one table. So you set up a pulley to place the string through at the end of the table. The length of string is then attached to a vibrator and signal generator and then the pulley, as shown here. The signal generator is turned on to ensure the string vibrates, producing the string wave, and so the mechanical wave is produced in the string. So the generator produces a wave which progresses through the string and produces this mechanical wave. So if we alter the frequency of the signal generator, we can alter the number of complete waves produced on the string, and this is the principle which allows stringed instruments such as guitars to play musical notes when plucked. And in addition, it explains why holding the string at different positions with your fingers will produce different notes on the stringed instrument. Now remember, the wavelength is the length of one complete wave, the distance from one place on a wave to the next corresponding point on the next wave. Now this means one wavelength is shown as 2 loops on a string. So to clarify, one wavelength is 2 complete loops, 2 wavelengths is 4 complete loops, 3 wavelengths is 6 complete loops, 4 wavelengths is 8 complete loops. So what you can do is you can measure the complete length of the string, then use the complete length of the string to find the wavelength of the wave. Now we can use this wave on a string to measure the wavelength and frequency of the wave. We can measure the frequency from the signal generator, so we can multiply the two values and we can use that to find the wave speed. You would then fill in your results table from the observation of practical activity, noting down the frequency, the wavelength, and then the wave speed. Now note you can calculate your wavelength from the number of complete waves on the string and compare it to the length of the string. So you do the length of the string divided by the number of complete waves on the string to find your wavelength. So what have we learned in today's lesson? That wave speed is equal to frequency times by wavelength, and you should be able to recall and apply this equation, and you should be able to make observations to identify the suitability of apparatus to measure the frequency, wavelength and speed of waves or in a wave in a solid and make appropriate measurements. So if you've been successful and you've learnt in today's lesson, you should be able to understand how to calculate the wave speed of a wave in a solid. You should be able to calculate wave speed from experimental values, then explain why different measurements are taken and how this takes place. I hope you've enjoyed today's lesson looking at the wave speed of a wave in a solid, which is part of the waves topic in GCSE Combined Science. Thank you very much and have a lovely day.